Okay, so I don't know if my my screen is showing at the moment, but today I would like to do some revision. So I've decided I'm going to go live to get my revision done. So um, my plan is for today. So I've already started doing some screen. Oh, I can hear myself now. Today Shush. Be quiet. Would like to do some revision. Shush. Thank you. Okay. So okay, you guys can hear me. Good, good, good. That's good. Now, so my plan is we're gonna do some electrode potentials first. I need to finish that off. That's what I've started already. Then I'm going to review year two integration, and then I'm gonna review normal distribution. So that's my aim for today. I just want to get those three things done. If I do, then it's a success. I'm actually filming. What? It's not showing. What's not showing? Oh well, I think it'll fix. I don't really know. I think the last time I did a stream was back when we were doing UCAT revision, so it's been a long time. So yeah, so my plan is to start off with some electrode potentials, um, and then integration and then normal distribution. So it should be fine. Should be a chill revision session. If you guys want to ask any questions, feel free. But my main aim for today is just simply answering some questions and doing some practice. That should hopefully be it. So I'm just gonna get straight on with it. Yes. Okay. Let me first share my screen just so you guys can see what I'm doing at the moment. I'm actually so bad at this stuff. I haven't done this in ages. Uh, okay. There you go. So I'm just currently making some notes on fuel cells. So I've done everything else. I'm just trying to do fuel cells at the moment. I'm currently actually filming another video. So my plan is for today is to film a video where I'm kind of like getting everything together and like all that stuff, right? So that's currently being filmed at the moment. And now during that video, I'm going to mention, oh yeah, so I went live and I continued my revision during my live stream. So hopefully that video is going to come out on Wednesday. So you guys should hopefully see that if everything goes well. I am trying to get back into the YouTube lifestyle. I'm trying to upload a lot more now. Now that I have the time. Um, okay. So let's just start. Let me just show you what I've been doing at the moment. So literally for the past couple of hours, I've just been working on making notes on electrode potentials because I haven't I've done this topic in class, but I just didn't pay attention to any of it, so I had quite a lot of stuff to go over. If I just bring my camera down, just give me a second. Let me see how I can do this. Okay, if I put my camera down like this, then I think you guys can see if you ignore the. Yeah, there we go. Okay, just about. Looks very messy. Let me move my. I'm gonna move my mic. So I've just currently been making notes on electrode potentials. Let me just get my pen. Give me a second. Okay, got my pen here as well. Um, I just need to make notes on fuel cells now, and then I'll be done with chemistry, and then I'm just going to move on to some maths. So it should be fine. It shouldn't be too bad. This topic's actually quite easy. It's not the worst thing in the world. I was expecting worse from year two chemistry, to be honest. It's not gone too bad yet. I mean, that's probably because we haven't started inorganic yet, but we'll see. We'll see how it goes. Let me just move this camera back to my face, my lovely face. There you go. It's a really like awkward filming setup. So I've got my camera up here. So if I'm looking at the camera, I'm staring like upwards. But because I've got my iPad down here, I'm probably going to be staring down for most of this stream. So yeah, let's. I'm just going to continue with my notes for some fuel cells at the moment. If you guys have any questions, let me know. I have been gone for a while. I did make that like update video, which I was meant to release yesterday, but I just was not bothered to edit it, and so I quickly got it out of the way today. And yeah, let me just go. So what I usually do when I'm making notes is I've got like Chemovise open. I've got the specification open. I've also got alloy chemistry open. Sometimes I have some other stuff as well, but usually this is enough for me to get all the information and then make it into some sort of legible notes. So I'm going to do that.
If you look here, we're going to look at a specific example for this one. This is an
I don't know if you guys can hear Mr. Alloy chemistry as well. Let me just reduce the volume a bit.
alkaline hydrogen oxygen fuel cell. There's an example of it. You can get acid ones as well. But this example, so you can see we've got a picture of the fuel cell on the left. And basically, what we're going to do for the next few slides, just look at what these numbers mean, what's actually happening after these, because you are expecting.
I'm just saying, I think the last time I did a study with me stream, I remember I didn't get any revision done. So hopefully this time can be different and I actually work. So if I can, so my plan is I don't want this stream to go on for more than 2 hours. Oh, actually, that's quite a stretch. Doing 3 big topics in 2 hours is quite a difficult challenge. I don't think I'll be able to do normal distribution during the stream, but I think I could get done with year 2 integration. So by the time it gets to 5 o'clock, I'm going to try and finish electrode potentials because all I have is fuel cells. And then for the next hour or so, and maybe a bit more, I'll just do integration. I think that's a solid plan. Let's do that. Let's do that. Okay, let's get the alloy chemistry video back up.
And then once we've done that, we then need
What you know, I don't understand fuel cells. I don't know what they were back in GCSE. What is this? Hydrogen fuel cell uses the energy from the reaction of a fuel with oxygen to create a voltage. I don't know what this means. I've understood everything else in this topic, but just I don't know what's going on here. I need to, after this, I'll make flashcards for this topic as well, and then I'm going to be done with this. So this is how long? This is, oh, that's it. Okay, so we only have we have this, and then we have this. That's it. Okay, I'm nearly done with this topic actually. That's fine. I can't lie. Year 13 A levels have not been as bad as I thought they would be. I think probably because after UCAT and everything, I'm just dead. So I actually like revising this stuff. Occasionally, some topics are still really weird, but majority of them are actually fine. They're not too bad. I was expecting worse to be honest, but it's all doable. There's nothing so bad that it's just not understandable at all. But some things just take a bit of time for it to click. I don't know what you guys think, but that's my opinion, I guess.
we then need to summarize it and look at the reactions overall. So that's what
Okay,
we're going to do first. So we'll look at number 1.
What is this? This is an alkaline hydrogen oxygen fuel cell. I don't know if has anyone else done this topic because I don't get what this means. So alkaline hydrogen oxygen fuel cell is an example of a fuel cell. So this is the one that we're looking at. Is that on the spec? Fuel cells are used to generate electric current and do not need to be recharged. Okay, so we need to know specifically about the alkaline hydrogen oxygen fuel cell. So that's the one Allery's talking about here. Okay. You know what? I agree. Maths actually. You know what? Out of the 3 A-level subjects I'm doing at the moment, maths has never been one that I thought would be very time consuming or whatever. Especially in year 12, single maths is so basic in year 12 for the majority of it. When we got to stats and mechanics, that got a bit long, but everything else was pretty fine for maths. But this year, the reason maths is just really annoying is just because it takes up so much of your time, and a lot of the topics can be really difficult to understand sometimes. So I might be able to do one question on a topic, but then I go to the next one, then I just can't do it, and I'm stuck there for an hour trying to figure out what to do. I think that's pretty. But then during an exam, I find maths the easiest to put up with. But then topic like a subject like biology or chemistry, I feel like during an exam it's much more difficult to do well in. Maths, I feel like it's hard to revise, but it's easy to do well in the exam itself. Um, but that's my opinion. The only reason I'm revising right now is because I haven't done much during the holidays. I've done a bit. I made sure that I hadn't piled anything up too much when I actually was in school. So I haven't left myself with that much of a workload. But I've got a Notion page where I've if it even loads, I don't think it's gonna load. Oh, there we go. So my plan is these are the topics that I have to do right now. So I've got this required practical to write up. I'm going to do that eventually. This was due all the way back on December 8th, and I haven't turned it in, so that's nice. I've finished parametric equations. I can actually click that as done. I've also reviewed parametric equations. So this is all I need to do right now. If I can get done with electrode potentials, and I can get done with integration 2 and maybe normal distribution as well, then I've pretty much left myself only like 2 or 3 things left. So I think I'm in a good position right now. I don't need to do too much, but I don't know, that's just me right now. I don't know if I have any other things to do. I think this is all the stuff I need to do right now. We'll see though, we'll see. I need to get this stupid fuel cells in my head first. Oh yeah, trig identities. They just keep on getting more and more difficult. Like they just keep on coming back. I didn't think trig was going to be such a big thing in year 13, but it's just annoying. Especially like the I don't even know what topic it was. One topic really did not sit right in my head for a long time, and then it finally made sense. I can't remember what it was now. Okay, let's do this. This is how much. It's like 10 more minutes or something. It should be fine. Okay, alkaline hydrogen oxygen fuel cell. What if I just write that? So electricity is generated by a continuous external supply of chemicals. I don't. Okay, that doesn't make much sense. Okay, this is useful. So the reason it doesn't need to be recharged is because it's constantly being fed with oxygen and hydrogen, so it maintains constant concentration. Okay, that's fair. I'll make a oops. I'll make a note of that. I think that's quite useful. I don't know if my yeah, further maths I don't get. I don't know how people survive with further maths because I'm here like struggling with single maths and it just takes up so much of my time sometimes. And then I just think about how further maths people did this all last year and they've got like twice more difficult things they're doing this year, which I can't, I could never do that. That's just too much for me. Maybe if like especially for medicine itself, like all the UCAS and the stuff specific to doing for interviews and things, maybe if that wasn't as time consuming. If I did a different career path or something, then further maths might have been more doable because it would have freed up time. But I don't know. I just don't like doing further maths and doing interviews and UCAS and personal statement and everything is so much. I could never. I really like fair enough, fair play for that.
Got a hydrogen bead here. So the
Okay, so
hydrogen
do I
bead
need to know this step by step?
say
Every single step. That's quite long. There's none of that on Chem Revise. But then if I check the specification, this is why I always have to use multiple resources because everything has different things dotted around, and so I can't trust just using one thing. I sometimes have like CGP open as well, but I think for A levels it's not as what's the word? It's not as detailed. That's it. Some of the things are very broad, and so it's not like as useful for me at least. But I don't know. I didn't use CGP much in GCSE either, just like the practice questions and stuff they'd have. But, yeah. Okay, let's do this. Fuel cells will maintain constant voltage over time. Um, I was gonna say something, but I know I need to revise, so I'm gonna actually sit here and revise. Hopefully, this could, if you're not celebrating Christmas, hopefully this could be a nice way to study with me. If you feel that you need to do some revision as well, but or you could just watch me revise. It's up to you. I don't know what I'm doing myself here. I said I was gonna finish fuel cells in the next 16 minutes, so I need to do that. Fuel cells. Did it say that fuel cells are they wait, they don't need to be electrically recharged? Okay, okay. Don't need to be electrically recharged. I'll write that down. Do you guys want to see a video of like how I make notes? Because I remember I put like a poll on it, and quite a lot of you guys wanted that. So I don't know. I might make a video on that very soon as well if you guys want to see that. I'm probably gonna start uploading more regularly nowadays anyways because I've got a bit more time. I've still got interviews and stuff, but it's not as bad anymore. Hello guys. Um, it's nice to see there's so many people here because all I'm doing is just sitting and revising. But I appreciate every one of you guys who stick around and watch my videos. So thank you. Um, I'm really good. Thank you. Thank you. If you want to revise with me, please do. Um, I am so sorry. Okay, I'm gonna try and stay in silence for the next like 15 minutes if I can. I don't think I'm gonna be able to, but we'll see. How much content? I just said I was gonna be quiet, but I see another question here. What was this question again? Um, how much content have you got left for chem and maths to cover? So for maths, we've nearly done with integration two on my on that teacher side, and then on the other side we're finishing up with normal distribution. So I'll talk about maths later. I'll stick with chemistry for now. Chemistry, we have finished electrode potentials. What's the next topic in chem? Let me just check. We finished acids and bases, so everything after acids and bases in physical chemistry is what we have left, if there is anything. Um, Inorganic, we need to do all of that for year two. Organic, we've done up until like amines, I think, or something. Yeah, and we've done a bit of NMR spectroscopy as well. I don't really know what we're doing with chemistry at the moment. It's all over the place, but yeah, we'll see. Media studies, drama, and dance. Yeah, sure. Okay. I mean, why are you asking me if that's calm? If that's what you want to do, go ahead. I'm not gonna judge. It's up to you. At the end of the day, What's your favorite revision methods? I mean, I think revision isn't something that's really that fun, I guess. But I mean, you kind of need to do a bit of everything. Like flashcards is nice and all, but I think doing past paper practice is actually, I don't know. It's nice being able to see like your progress over time and stuff. But I don't know. Let's um let's continue with this chem and actually revise. Where did my I lost my notes. Here it is. Okay, let's do this. So what do we say? Fuel cells don't need to be electrically recharged. Yes. So now we need to go over the steps and everything. The reason they don't get recharged is because uh, they are fed with like Cameravise's description a bit better right now. But sometimes Cameravise just doesn't go into enough detail, or it says things that just don't need to be said because it's just way too complicated. Oh yeah, Bison Maths is quite useful as well. I personally, for maths, I don't really watch many like videos for maths because for me the main issue isn't really understanding it, it's just doing questions for it. So I'm usually always just doing like the the questions for it. I don't know, but integration I might have to be watching a few videos because it's a bit confusing, especially for the year two stuff with like the reverse the reverse thingies. I don't know. I haven't been paying attention in class, so I don't even know if it's hard or not. I just remember that when I was doing integration in class, I kept on differentiating it instead of integrating it, and I wouldn't realize that or forgetting plus C. I know this is common, like basic year one errors, but for some reason I keep on making them. Okay, I've been on the same line for the past like 10 minutes. I need to do something. Maintaining a, what was it? Maintaining constant concentration. That's what it was. Okay, so I've done that. Now I think I can go over the steps for this alkaline. So this thing, the stuff that Mr. Allery Chemistry is going over. So I'm gonna make a note of that. What is this called? Alkaline hydrogen oxygen. I don't even know. Wait, if I do this, I think all you see is my hair. That's I don't even know how to fix that. If I like put my camera like, either way, this is the annoying thing. I need to fix my entire streaming setup and everything at this point. But now I'm just gonna stick with this, though it should be fine. This is giving me like UCAT flashbacks though. Hydrogen oxygen. Oh, I'm on the wrong thing. It's this one, isn't it? Fuel cell. That's what it was. Okay, I'm first going to listen to what he's got to say, and then I'm going to make notes on this, because I don't know if any of this is necessary. It probably is, but I don't know if it's as necessary as the amount of detail he's going through with this.
Reacts with the OH minus ions that actually come from this side of the reaction, which we'll look at in a moment. And basically, the hydrogen reacts with the hydroxide ions to form water and for electrons.
Okay.
So then the flow of electrons, this is point 2, the electrons produced in that part travel through the platinum electrode and through the wire. So remember, platinum is good because it's inert. It's a good conductor of electricity. So the electrons
Wait,
flow
electrons
through here,
produced
and this flows
travel through platinum electrodes because it's inert. Yeah, I remember that. Where is it traveling through? Oh, I see, over here. So it goes up, goes through the, is that a resistor? I can't remember the physics things. I think that's a resistor, right? The like the spiky thing. I'm so bad at this.
through the third section, which is the component. So this could be, for example, a car.
Component. I thought that was a resistor. Wait, is that not a resistor? Wait. I swear resistors look like that as well. I might be wrong. Let me just check. Resistor circuit symbol. Yeah, wait, no. I'm right. Fixed resistor. I guess any random component. Oh, I just realized I'm not showing my screen. Yeah, look. Fixed resistor. Spiky lines. I don't know. This is why I didn't do physics, because I'm clueless when it comes to physics. The only part of physics I somewhat understood was like radioactivity, that stuff, like alpha, beta, gamma radiation. That was actually quite interesting. And space. Space was quite cool as well. Just reading what's going on in the chat right now. Resistors a box. Then what? Oh, I don't know. Who cares? Who cares? We're just gonna go with the spiky lines for now.
House view these fuel cells. So anything like that, this is where the use comes out.
Okay.
Okay. So now moving on to step 4, which is this bit, and this is basically where oxygen is fed.
I kind of remember this from GCSE.
So this reacts with water, and the 4 electrons that are being produced from this side to make the OH minus ions that we need to move this over here. Up a bit. So the overall reaction is oxygen coming in, reacting with 2 lots of.
Okay, what is going on? I wasn't paying attention for like 2 seconds, and it's already like ramped up. That's crazy. What? Okay, so oxygen's fed into the thing as well now. It reacts with the water. Why is there water here? When did we have water here? Wait, what? Oh, okay, so that's where the water gets formed in reaction number 1. Hydrogen reacts with OH minus ions, forming the water and E minus. Water then reacts with oxygen, forming OH minus ions now. Okay. And it reacts with the electrons as well. Negative electrodes. Okay. So what was the one before? The positive electrodes, right? Surely. Oh, it doesn't say. Okay, this is making a lot of sense. Okay, and then electrolyte. Okay, so that's potassium hydroxide solution carrying the OH minus ions. Then we've got the positive electrode. I see. Okay, so where's this now? That's the one over here. Okay. Product of the reaction in step 1 is released into the surroundings. And then this is so confusing. Do we need to know all of this? Because I'm looking over here and I'm not seeing any of that here. I'm just seeing like this really brief diagram. And the specification's not helping either. All it says is the electrode reaction. Oh, actually, electrode reactions. So I'm guessing it means all of the reactions we're talking about over here. Okay. I said I was going to be done with this by 5, and now this is looking a bit long. Okay, we'll see.
Ion exchange membranes as well, and the ion exchange membranes actually sit on the electrodes, and they sit on the side where the electrolyte is. And these membranes allow the OH minus ions to pass through,
Okay.
but not the hydrogen and oxygen gas. Because the last thing we want to do is
Just
allow
mix
hydrogen
the
and
hydrogen
oxygen
oxygen
gas to pass
gas.
through and meet. Because
Yeah.
the electrons will be transferred here, we won't actually get the benefit through the wire. So that's why we must keep them separate.
Makes sense. Sort of.
So to summarize through here.
Please summarize. Oh wait, so you're just going to repeat
Yeah,
everything you said?
And then the thing we want to do is to allow hydrogen and oxygen gas to pass through and meet, because the electrons will be transferred here. We won't actually get the benefit through the wire, so that's why we must keep them separate. So to summarize, the first step is the hydrogen feed. So the hydrogen is actually fed in through here, reacts with the OH minus ions from solution from step 4, which is here. They come from the solution step 9. So the overall reaction is 2H2, 4OH minus, producing 4H2O and 4 electrons.
Oh, I need to know
Now,
these
the
equations.
oxygen then is fed on this side.
What?
So this reacts with the 4 electrons that come from the hydrogen feed, and this produces the 4OH minus ions, which are then fed through to feed on this side. So it's one big circle, as you can see. Now we can combine these two equations and cancel out any species which are the same, such as your waters and electrons, etc. And we form this overall reaction, which is showing what's happening.
Chill out.
So effectively, it's 2 lots of hydrogen reacting with your oxygen, which is here.
So that's all we need to know, not the waffle that he said before. The waffle he said before was simply just to understand why everything's happening, I guess. So should I make a note of that then? I think I will, but in much less detail compared to what he's writing, because I don't think any of this is needed. As in, like, it's needed to understand what's going on, but I don't think I need to be able to recall this. When I do practice questions, I'll add to this stuff as well, because I'm a bit unsure. Everything else in this topic has been quite straightforward. It's just this one fuel cells thing that's kinda confusing. I don't really understand what I need to know from it. Am I behind on my flashcards? I was before, sort of, but I still managed to like somewhat keep up with them. I know that I've got quite a lot to review right now, but I'm gonna try and get it all back on scratch this holidays as well. So I think I should be able to do that as well. It's not too many because I remember I was going over my flashcards as revision for my Cambridge interview, so I managed to get through a lot of them anyways just for that. So it's not too bad. It could be worse right now, but yeah. Let's see.
Minus ions here from the cathode, this bit, to the anode, to this side.
Yeah, I don't recommend choosing a subject for A level because it's easy. Make sure the subjects you choose are. I mean, if you find the subject enjoyable and you think you'd be able to put the work in, there's no easy A level. You just need to put work in for them. I mean, some subjects are just notoriously more difficult than other ones, but that's just because they're more science heavy. A lot of the sciencey and like essay subjects are usually quite difficult from what I've heard. So I think as long as you know that you can put the work in yourself, like chemistry, for example, it's horrendous. It's really, really bad. But I think if you can put the work in and you can somewhat get through it, it's not that bad. It's just you just need to be able to go through it, if that makes sense. I don't even know what I'm saying at this point. Some chemistry topics have literally led me to like the point of like I don't even know because like some of these, especially last year, a lot of the topics are so confusing. This year's not been too bad. Acids and bases did kind of like finish me. Every lesson though, during class, I'm just there complaining about every single thing that the teacher says because none of it makes any sense, and I'm just like, "What are you saying?" It's just it doesn't make any sense half the time. But then when I go over it at home, it's fine. This I don't know what's going on. I'm trying to understand it. It's sort of making sense. What? Sorry, I'm just hearing some fireworks outside. Very confused where they're coming from. I don't know if you guys can hear that, but yeah, we'll see.
At 7, this is your positive electrode.
Oh,
This is
stop. Why
Nouman.
is it at 7 already? Wait, go back, go back. I need to understand this again. So we're going to start with 1 again. This sort of makes sense now. So we've got hydrogen being fed in.
Water and 4 electrons.
Okay. I'm going to start making a note of this stuff now. I think I've understood it enough that I could probably move on to questions after. But let me just make a note of this stuff first. And then, should I draw out that diagram? I think that's quite a confusing diagram. Let me see if there's any better ones. What is this called again? Alkaline hydrogen oxygen fuel cells. I normally don't like copying and pasting diagrams. I always draw them myself. I don't know why. It's just something about me. I always have to draw the diagrams in myself. Okay, all of these diagrams are just pretty much the same. Let me just show you. They just look like this. I think I can draw these. This looks drawable. This one seems fine. I'll draw something like this. Let's see how well I managed to do this. So we've got hydrogen coming in. Yeah, so it comes in like this. I'm gonna stick to this diagram. I feel like this one's easy to draw. Oh, oops. You know what, let me just show you guys my lovely artistic capabilities here, just in case you wanted to know. This is my drawing right now. So now I can add in my electrode. So that will be this one here. Then we can add straight line like this. Now what do we need? Something like that. Oh. This is looking very confusing right now. I wish my teacher explained this to me. I don't even know what I'm doing with this topic anymore because I remember our teacher kind of went through it and it didn't make any sense to me. So I don't even remember my teacher going over this topic though. Like they finished the topic of electrode potentials, and I don't remember them actually going over this. Maybe it's because I wasn't paying attention because I had interviews to worry about, and but it should be fine. I think I can always change it later on when I see how the questions are worded. Maybe that will give me a better idea of what I actually need to know from this topic. And then we'll draw a nice circle. I know it's upside down for you guys, but this is looking. Oh wait, why am I drawing this? I was gonna. Oh, oops. Oops, wrong thing. I need to draw in the squiggly lines. Oh, that looks horrible. That actually looks horrendous, but I'm gonna keep it because it looks kind of funny. Okay, I think I've done everything now. So I've got. Oh, the one thing I have left is this line over here. There we go. That looks decent, and then I can start making it look less complicated because I don't want to include every bit of stuff that this guy told me. We'll see. Yeah, the only way, let me go. I don't know if you guys still want to see my drawing. I'll show it again to you guys when I'm done with it, but right now, oh, actually, let me, this drawing's really bad, but some other drawings that I've made are actual, like, artworks. Like, if I just go back up a bit, I'm very proud of my, let me show you this. I'm very proud of my, I just realized this entire time my camera was only in, like, the small circle mode. I'd do that, there we go. How do you guys like, oh wait, let me put it the other way around. Yeah, look how beautiful that looks. I don't know, maybe it's just me, it just looks really cute. But I just like drawing everything in myself because it makes it easier for me to understand what's going on because it's my own drawing. But I don't know, that's just me. Um, yeah, let's continue. Let's continue with the drawing. Okay, I did say I was going to be done by this by 5. We're going to change the time. We're gonna finish this by 5:30. Let's say that. I think we'll be done by then. Okay, let's go back to my drawing. Just trying to understand this diagram right now. So we've got hydrogen coming in here. H2 in, and then water and heat. What? Heat? Do I need to include heat in my diagram? Let's see.
So then the flow of electrons, this is at point electrode, this is the anode.
Oh, I kind of see why he's put so many points in because he used this diagram, so he had to label every single point. Okay, that makes a bit more sense. So yeah, I'm just gonna say water gets removed rather than water and heat because no one cares. Oops. Let me just put H2O out here. And then what else do we have? We have oxygen coming in too, and that's it. Okay, this is not too bad. It's still quite an ugly topic. I don't like it, but yeah. Okay, so what do we have now? I've drawn this in. We've got the. I just realized I still don't understand what's going on in this fuel cell. It still doesn't make sense to me. Let me just go over it one more time. If this guy still fails to explain it properly, then, or maybe it's just me and I can't understand it, then I'll get another video up and have a third video
thing. Anything like that, this is where the use comes out of it. Okay, so now moving on to step 4, which is this bit.
Oh, wait, why are we at step 4? Go back. There, okay.
Power in a house if you had
Hydrogen's fed in. Electrons flow. How am I going to show this on my diagram? I just don't like the way they've shown OH minus ions here and hydrogen ions. They look very confusing. I don't know. Okay. Let's put this on my diagram. So we've got OH minus ions going from. So which one here is the anode and cathode? We've got this one here is the anode. So that's the left one. And this one here is the cathode. I wish I remembered this from GCSE because it actually made a lot of sense to me back in GCSE, and now for some reason it doesn't, which I don't know what's happened, but it is what it is, I guess. and it's taking me this long for it to get back into my head. It's still not properly in my head, but eventually it'll make sense. Is this OH minus ions? Yeah, it is OH minus ions, and we've got electrons here as well. Let me just show the flow of current as well. Okay, and now we've got hydrogen coming in. What color does hydrogen become? Let's make hydrogen a red color. And we're going to make water blue for obvious reasons. Okay, now I can show this on my diagram. Okay. I'm nearly done with this topic. Get this topic out of my face, please.
Yourself.
I hate this topic so much.
This is where the use. Okay, so now we're moving on to step 4, which is this bit, and this is basically where
Okay, so
to power a car.
That's the first equation we need to know. Hydrogen feeds the 2H plus. Let's write that equation down. Hydrogen reacts with OH minus ions, resulting in the following reaction. You guys want to see my diagram now? Let me just change my camera angle again. Oh, I'm upside down now. There we go. That's currently what we're dealing with. Doesn't look too bad. Oh wait, sorry, I'm not even showing the diagram. There it is. That's the diagram. I think I might add a few more things to it, but for now that's yeah, actually that should be fine. We'll see though. If I need to add anything else, I will, but for now I'm just gonna put in the equation. So what's the equation? It's 2H2. How am I gonna remember this? This is just long. This is how I feel about all of chemistry. There's so many equations that I just don't care about. OH2O plus 4E minus. There we go. So that's step 1. Then what? We can remove. Are we going to mention every single step? This thing's long. Let's see. So, got. Actually, let me go back to my browser just so you guys can see that. There you go. Hello, I'm back. Trying to fix the camera again. There we go. So the hydrogen reacts with the OH minus ions, forming water and E minus. Then that reacts with. Oh wait, what? So it now goes through the electricity circuit. Yeah, that makes sense. Then oxygen reacts with water. Okay, so I'm gonna mention that as my second step. When it says it reacts with water, what water is it reacting with? Is it the water that got formed back here? I'm guessing so, right? But why would they not say that? Why would they not say it reacts with the water? Oh wait, no, it does. Oh, I'm so silly. This is what chemistry is doing to me. Yeah, this is A-level chem right now. I mean, technically, this is a GCSE chem, fuel cells. This is the part that didn't make sense to me. All the A level stuff did. Now I'm stuck on the GCSE stuff. This is embarrassing. The oxygen reacts with the water and 4 electrons. And that forms OH minus ions. Okay. This is making sense now. Let's go. We've got oxygen. Got water. I apologize to anyone who's actually trying to revise here and is just hearing me just yapping about chem. Or OH minus ions. There you go.
Which is this bit. And this is basically where oxygen is
Yep.
fed.
We get it, Allery chemistry. Shush. Move on, please. Thank you. So a lot of the things he said was like straightforward enough that I don't think I needed to write it down. Electrolytes made from the potassium hydroxide. So the electrolyte's number 9, isn't it? As in like it's the solution in number 9. Okay, so I'm gonna write that down as well. Solution. This is giving me what is that thing called again? Electrolysis. That's where this topic was from back in GCSE. Does electrolysis even exist in A level? I don't think it does. I mean, this is the closest you get to electrolysis. I'm doing my GCSEs this year. I'm wondering how much I should be doing in my holidays. These holidays. I'm just trying to remember what I did during these holidays. I don't think I did anything purely because I had my GCSE mocks and then right after I had my holidays, or like soon after I did. So I didn't really spend my. The only thing I recommend perhaps doing in your holidays is making sure that everything you've learned up to this day makes sense. So there's no lessons that you've had that you just like forgot about the topic and you're like, oh, that doesn't make sense, but I'll just not go over it. So make sure that every topic at least you're familiar with, but you don't need to do any proper practice or anything. Maybe just make sure you have your revision materials and everything in place. If you don't, maybe like work on those a bit. But I don't recommend doing much in these holidays. Honestly, I'm not doing much in these holidays either. This makes it seem like I'm just non-stop revising my holidays. This has been the first day I've actually picked up my pen and actually done a bit of revision. I did parametrics a few days ago, so a parametric equation in maths, but apart from that, I haven't done anything. So I really recommend spending this time actually just relaxing because I mean everyone deserves it. But if you do want to make sure that you get something done, that's what I'd recommend. Perhaps just making sure your revision materials are in place and everything. That's my advice, I guess. For me, as an A level student, the only thing I'm doing in these holidays is making sure that I've reviewed everything because that's something about A level. You have to make sure that every lesson you've done, you've reviewed because you can't really just go over everything all at once right before your exam, just like how you could in GCSE. You just can't do that in A level. Or at least if you do, you're not going to get a good score because there's no way you can go over everything in enough detail.
At 7, this is your positive electrode, anode. This bit here, and so electrons flow from this.
Yeah, I know. Move on.
So that's all
Thank you.
symbolizes.
Okay. So OH. Wait. So is that all the equations? Wait, what? Oh, it is. Oh, and then you've got the overall equation. That's the last equation we need. Okay, that's fine. OH minus ions produced from reaction 4 are carried towards the anode. Okay.
And a bit through the wires.
This is fine. So all I'm going to mention is overall reaction is 2H2 plus O2 gives you 2H2O. Let's go. I did it. Finally. now I need to make flashcards for this, and then I'm done with chem for today. Finally, this took way too long. Let me just make sure everything in my notes is fine. Yeah. They are fed with fresh O2 and H2. Can't believe I'm in silence for once. I'm actually focusing. This is crazy. Okay, so I've done my notes. Let me just show you the finished product. If I can, if it even lets me. Yeah. Okay, so, and if you can see, that's just one page. We've got like a bit more other stuff as well up until there. Electrode potentials, yay, let's go. Okay, now I'm done with this. Oh, I just realized I haven't highlighted this part here. As in I haven't like changed the color of it. Okay, now I'm done with electrode potentials. I just need to make flashcards for it. I'm going to do that real quick, and then I'll finally be done. So let's just do that. Let's get RemNote back up in here. I don't think I've opened RemNote in a long time, as in like a week, which is a long time for RemNote because I always need to do it daily. But yeah, let's see. Let's see how my flashcards have powered up. It shouldn't be too bad right now. 200 flashcards. That's not the worst thing in the world. That's doable. I can get that down. That's fine. Yeah, that shouldn't be too bad. Most of it's from chemistry, which is understandable. That makes sense. Let's just get chemistry up in here. Let me just show you how my RemNote's coming along at the moment. There we go. So the red stuff are things I haven't gone over yet. I did this back when I had my end of years, so I just needed to make sure I knew what topics we'd done and which ones we hadn't. Because what is this? Why is it not removed? Oh my, no, I don't want. Why? What? Why? Okay, I don't know what I'm doing right now. Okay, I've just opened up the specification for some reason. Let's get rid of that. There we go. So what I was saying was the red topics here are topics I haven't covered yet. As of right now, I have actually covered aromatic chemistry, sort of. I'm still doing that. And amines we're kind of touching now as well. In terms of inorganic, I haven't touched any of these. We've just started transition metals. It's not the worst thing in the world, to be honest. I was expecting worse, but then again, I haven't done anything in it. Rate equations we haven't done yet, which I think we're going to do after. Yeah, I think we're going to do that next. Oh wait, we've pretty much done all of physical chemistry. That's crazy. Oh wow. Okay. Yeah, I've done all these other topics. It's just electrode potentials I'm doing now, and rate equations is the last one that we're going to do. Which I don't know why it's the last one. I don't know why we didn't do it in order, but that's fine. It doesn't look too bad. Okay, I just need to make flashcards here. It's all empty at the moment. When are your mocks? I actually can't remember when my mocks are. They're like, I'm just trying to remember. I think the end of February or something like that. During February sometime. And how many hours am I planning to do in a day? Honestly, I never track how many hours of revision I do in a day. It's always about what tasks I have, and if I get the tasks done, I'm done. So in this case, I have 3 tasks to do: reviewing electrode potentials, which I've spent about 3 hours on now. um, Reviewing year 2 integration, which is probably going to take me another like hour or two, and then reviewing normal distribution, which I don't think I'm going to be able to do today because I spent way too long on electrodes because it was a huge topic, to be honest. But yeah, so I think overall, I'm not going to have a consistent amount of hours I do each day, but I'm planning on hopefully getting in at least an hour from now, or at least like when school starts again, an hour a day, focusing on specifically just going over like past topics that I have not touched in ages. So um, that's what I'm trying to do. But we'll see how it goes. I'll make some videos on GCSE mocks. I'm not GCSE, I mean A level mocks and how they're going and what I'm doing for this. This is RemNotes. I've got an entire video if you want to see. It's just a flashcard software app. It's pretty much the same thing as Anki. I just like its interface a bit more and the way like you make flashcards on this one. It's more like note based, I guess. That's the only reason I prefer it. But there's nothing like against Anki. Anki is decent as well. I got all eights and nines and a seven in my mocks. When should I start revision and what should I do to get all nines for the real thing? Um, my best advice is to start 9 weeks before, as I did with the 9 week revision plan. But that doesn't mean doing the same amount of revision from 9 weeks all the way to the last week. Rather, spend. So what I mean by the 9 week revision plan is the very first week of the 9 weeks to start understanding where you are at everything and start slowly going over those past topics, and then as you get closer and closer each week to add a bit more of stuff you do each day, maybe instead of doing only one past paper a week, to then do two past papers a week, and then suddenly do like a past paper a day. Maybe it really depends at the pace you feel that you need to go on yourself. But yeah, my best advice is 9 weeks. 9 weeks is a good like place to start. But yeah, I to be honest, GCSEs is not that hard to like cram. Obviously, I don't recommend it, but I know a lot of people who did and still did really well. So it's not really my best advice is to start 9 weeks prior. That's like the best thing you could do probably. And before that as well, that's a good idea as well. But my like try and make sure 9 weeks is like the time you start at least. If you're not doing anything 9 weeks before your exams, that's a bit of a problem. You need to start going over that stuff. But obviously, don't do too much each day at the very beginning. Um, Yes, let's make some flashcards. We should be done with this in about 5 minutes. We can do this very quick. Let's get my. So what I usually do when I'm making flashcards is I get my iPad's notes on my left hand side here, or my right sometimes, and I just sift through everything. One thing that's really useful is if I copy something on my iPad, I can just paste it straight into my Mac, which is very useful because it just saves a lot of time. So electrochemical cells are made of two half shells cells. That's what I mean. So I'll write what are electrochemical cells made up of, and then I'll write wire, voltmeter, and salt bridge. Oh, actually, let's separate them out just so it's easier for me. So we'll put wire, and then voltmeter, and salt bridge. And then I'm also going to put an image for fun. I just copy and paste it from my iPad. Oh, actually, let me just copy and paste the entire image. And I'll make the image into a flashcard. That's actually probably a good idea. So we'll put the image as a separate flashcard, and I'll make it like an image occlusion flashcard. So I'll just wait for the thing to load. It's still uploading. There we go. I'm just checking what you guys are saying. Yeah, I've started transition metals right now. Like, I mean, not right now, as in when we were at school, I've done like 2 or 3 lessons on it. It's okay. When we started the drawing, I was like, what is going on? The drawings are so confusing, but it's not the worst thing in the world, to be honest, at the moment. But I've had a lot of bad things about transition metals, so I am preparing for the worst. But we'll see. We'll see how it goes. Okay, so we're gonna label this diagram. We'll put that there. We'll put this here. And I think that's it. Oh, I just dropped my phone. Let me put that up. Okay, I think that's fine. I don't think I need to put salt bridge as a flashcard. I think I'll always know that's a salt bridge. That's probably not something I need to make a flashcard. I don't even know why I made the voltmeter one, but I think that's fine. I'll just keep it like that for now. We'll see. I'll edit it if I need to. Now electrode potentials. Okay, if a current is allowed to flow, a redox reaction occurs. Okay. Half cells have an okay. I'm just thinking of what I can make into a flashcard. How can you use the electrode potential? I need to find out if this is a long flashcard. I might have to reword it. How do I show like theta on my rem note? I don't know how to do that. Let me search theta electrode potential value. I don't think I'm gonna stream tomorrow, but we'll see. I'm trying to get all my work done today, so I don't need to stream tomorrow. That's the entire point of this. But if I do have a bit of work to do tomorrow, it'll probably literally be like half an hour to 1 hour, so it won't be like that much work I need to do. From tomorrow, I'm probably going to start focusing more on. Cause I'm actually going to start working from this week, as in like I'm not going to do too much. I'm still going to enjoy my holidays, but I'm probably going to start slowly reviewing the things that I've gone over. But yeah, there we go. So I've put the value. This is what I've put. That looks good enough, right? So I'll just copy and paste this when I need to. Electrode potential. Let's do this. So I'll put alloy chemistry's thing here as well that can help in terms of like remembering whether or not if you don't do chemistry right now and you're looking at this, it probably makes no sense, or if you've not gone over this topic. But for the chem people that have done this topic, hopefully it makes a bit more sense. Let's see. I'm just thinking of what else I can make into flashcards here. The entire topic isn't that bad. It's just the fuel cells that kind of. Oh, I just realized I haven't gone over. I haven't made notes on one part of fuel cells. There's also like limitations and things of fuel cells that I need to do. I'll do that. I'll be fine. Let's just make flashcards for these things first. Oh, I didn't think this was going to take this long. I'll do yeah, okay. I think I'll start integration, but I don't think I'm even going to finish that on stream. I might finish it off later in the evening if I can be asked, but I don't really care about this anymore. I'm starting to lose my will for revision right now. Components of the standard hydrogen electrode, or known as the She. Okay, so what do we have? Hydrogen gas at 100 kilopascals. We have 298 Kelvin temperature. We have solution of 1 mole per decimeter cubed of H plus ions. I'm also going to put in brackets, e.g. 1 mole decimeter cubed HCl, just so I remember, or 0.5 H2SO4. Oh, I can't be asked to. Okay, so whenever I'm putting in like H2SO4 or something, I would bring this up. I've done this so many times I can just remember the code. So it's like this. And then inside here I can put H2SO4, and look at that. Perfect. And we have a platinum electrode. So it's basically standard conditions, pretty much. And we're also going to put a lovely diagram of the She. And we'll just chuck it in here just so I can remember it. Yeah, I did the alkaline hydrogen oxygen fuel cell thing, but I forgot to do the limitations and stuff. That's the only problem. It's annoying. That's fine. I got a 9 in French speaking and writing, but a 6 and a 7 in listening and reading. what do I do to get listening reading to a grade 9? Well, at the end of the day, when you're actually doing the A level, I'm sorry, not A level, when you're doing GCSE French itself, all of the four aspects are going to combine into one, and you're going to get one score. So um, I think the best thing to do is to make sure your speaking and writing is as good as it can possibly be, and then for listening and reading, I've got a few videos and things that you can do to improve them, but you're most likely not going to do as well in them. Just statistically, most people don't do as well in reading and listening as they do in speaking and writing. So just try your best to make speaking and writing really, really good, so you don't need to worry as much about listening and reading affecting your grade as much. That's pretty much my advice. But I do have like videos on GCSE French and things to do specifically if you want to get better at reading and listening. But if you want to check those out, I can't even remember the things I said in them now because it's been very long. My main advice would just be making sure you do lots of practice and you are very familiar with the vocabulary. So constantly do vocab practice. Okay, now we have standard cell potential EMF equation. And then we can copy and paste this. This is the beauty of airdrop. I can just literally copy and paste. And now, there we go. Perfect. It's right there. Should I put an example? I don't need to. Okay, cell notation for electrochemical cells. That makes no sense. I'll put notation for electrochemical cells. That makes a bit more sense. Have you got any tips for doing A-level maths and chem? I started chem getting A's, but now I'm working the same and getting D's. I think A-level chem is crazy. It's honestly, I think my best advice for A-level chem is just as the other person said, just be consistent. Do because it's so the difficult about chem is it's so easy to forget everything that you have to constantly be going over it. So as long as you're doing a lot of practice on it, it should be fine. Just constantly be going over those old topics again and again and making sure you're really familiar with the questions. I think that's the best thing you can do, in my opinion. But genuinely don't be too disheartened if you suddenly get a drop in grades for chem. That's normal because chem is not a subject that you can easily guarantee anything for. It's just really just dependent on what topic you're doing. Some topics are significantly easier than other ones. It's really like imbalanced. That's an A level in itself. A level French was I remember I did it for like a month or two. It was not the best thing in the world. I enjoyed GCSE French, but A level French you need to put in so much effort, and it's just I didn't want to do that, so that's why I dropped it. Okay, so we're putting in the reduction oxidation stuff now as well. I'll chuck that in. I'm also going to put an example one in, just so I remember how to do these. You can see a lot of my flashcards are mainly based upon my notes, so there's a lot of screenshotting and things that takes place because it's all just pretty much my notes, but just transformed into a way where I can actively review them. Are you actually? Do you have any ways to cheat in exams? Are you really? You're asking me about that? Okay, I'm just gonna pretend like I didn't see that. Yeah, exactly. There's some of the things I see when people like try and cheat. At that point, you might as well just provide. But yeah, the best cheating method is to sit down, open up your book, make flashcards, review them constantly so it goes into your head. So when you're actually in the exam, all you're doing is you're writing everything that's in your head. So you're just cheating because you know the information. Easy, honestly. Let me just copy and paste this. So the notation for this one would be like this. My flashcards aren't the prettiest looking things, but like they don't need to be. My notes don't need to be very pretty either, but I just like making them pretty because it just makes me feel happy and it motivates me to. I don't know. It just like that's not. That's just a personal thing. There's nothing that makes it so you have to have them looking nice and things. Honestly, it's probably a waste of time, but I just like doing it. So, oh, oops. So what have I just done? I guess it helps me in making sure I understand everything. If I make it nicely laid out, then it forces me to write it in a way that it makes sense. Yeah. Okay. Honestly, this is probably one of the easier topics in A-level chemistry. This one's not that bad. The very ending was a bit confusing, but most of it is really easy in this topic. It's actually fine. Don't worry. You don't need to worry about this topic. Acids and bases, oh my gosh, I hate that topic so much. It actually has to be one of the worst topics I've done in chem. Honestly, that one, the amount of time I've spent staring at the same question for literally like hours just because I don't know where to start. And I'd have the answer in front of me and I just wouldn't know how it was the way it was. Like the amount of times I went up to my teacher and was just venting about the topic because it just made zero sense. It's just, yeah, it was a nice time. Okay, now we're looking at batteries, electrochemical. Okay, let me just talk about specifically lithium ion cells. Equation for lithium ion cells. I'll put batteries, or should I put cells? Okay. Obviously, I have to put this one over here as well. Just for, okay. Now I can write equation there is no way I'm writing this equation out. I'm just gonna copy and paste it. There you go. Lovely. And now fuel cells, my favorite topic. We all love fuel cells, you know. This took me about like a half an hour to understand. Lovely topic. Why don't fuel cells need to be electrically recharged? Answer, they are fed with fresh oxygen and hydrogen. There you go. Steps for alkaline, hydrogen, oxygen. I love how I said I was going to start integration at 5. It's now 5:44 and I'm still doing electrode potentials. This is great. Time to copy and paste another equation. I wish I had good chemistry teachers, because then all this stuff would have made sense. I wouldn't have spent 3 hours simply understanding this topic. But last year I had one good chemistry teacher, and now I have two bad chemistry teachers, so that's nice. Before I had one bad chemistry teacher, so it's just lovely that now every lesson makes no sense. I think that might also be the reason I have such a problem with chemistry. It's just taught really badly for me, so I just never understand it. Yeah, I use good notes for my when I'm making notes during class and at home. There we go. This is looking lovely. Now the last thing I need to add, the thing I forgot, was the limitations and the benefits, advantages of fuel cells. This looks like common sense. I mean, most of the stuff I think I'm still going to write it down though, just in case. But this seems fine. Okay, let's write this down. And then after this, we're done. We're done with this stupid topic. And then I'm going to do some integration for fun. Not for fun, obviously. Integration's boring. Actually, integration's not too bad. Anything that isn't mechanics, I'll be fine with. Mechanics is boring. Actually, saying that as well, mechanics isn't the worst thing in the world. I don't know. There's some topics in maths just I don't care about. Okay, let's quickly do this. We'll be done by 6, definitely at this rate. Okay, advantages of fuel cells. What do we have? Less pollution. Let's see what allochemistry is saying if he says the same things. More efficient. Don't need to be recharged. No carbon dioxide emitted. Okay. And what does Cameraby say? More efficient. Less carbon dioxide. Same thing, pretty much. The only thing it neglects is the fact that it doesn't need to be recharged, but we've already established that, so it's fine. So let's just say more efficient. Who knows why it's more efficient, but it is more efficient. And less pollution. Okay. And now limitations. And then they talk about ethanol fuel cells, which I don't see in the specification. So I don't know why it's talking about that. Alloy chemistry doesn't seem to be talking about it, so I'm just going to ignore that part. Okay. So what are the limitations we've got? Expensive. That's fair. We've got storing and transporting is what? Storing and transporting hydrogen in terms of safety, feasibility, and the limited life cycle of a solid adsorber or absorber. What does that even mean? Where's the limitation? Limitation is the fact that you have to store and transport it, and it's potentially unsafe. Let's see what alloy chemistry says. I like his explanation's a bit more here. Okay, highly flammable. I'll put that one in. Energy is required. Okay, done. Now I just need to make 2 more flashcards and then we are done with this topic. We'll be done early with this topic. I said at 6 o'clock, but looks like we're going to be slightly early. Okay, let's do this then. Okay, so you've got advantages of fuel cells. More efficient, less pollution. Disadvantages of fuel cells, or limitations. We'll write limitations instead. What do we have? Expensive to transport. Energy is required. So usually from fossil fuels. Okay, we did it. Now, one other thing I do when I finish reviewing a topic, or we can actually mark it as complete in our Notion page. I might make a Notion video as well in case, because I've only started nowadays using Notion a lot more. I don't know if you guys want to see that. We've done this, done there. Okay, so now I review these flashcards just to make sure I understand this stuff and I've actually learned something today. So let's do that and then we're done. We're done with this topic. Okay, notation. Let me just draw it up over here. So it's like R, O, O, R. You've got lines like this. So a single line means change in state. Double line means salt bridge. Usually the more positive ones on the right and more negative one in terms of the E value is on the left. That should be everything. Let's go. Okay. Oh, this one looks confusing. So you've got 2 equations here for lithium-ion cells. What is the overall equation? Well, we know that this one's more positive, so that means this one's going to get reduced. Hence, this one's going to be oxidized. If that's being oxidized, that means you have to change the equation. You have to flip it, basically, to this. So the equation's the same, but it's the fact that it's flipped that's important. So now we've got 2 equations. We've got this equation, we've got this equation. Now we can combine them. We can cancel out the Li plus and cancel out the E minuses. So we get COO2 plus lithium becomes Li plus COO2 minus. Okay. Oh, I forgot the second part. Yeah, if it's the fact that it's discharged is when that happens, and when it's recharging, it reverses. Yeah, I got everything else though, so I'm gonna give it this standard, like a standard cell potential equation. So that's the one where it's E reduction minus E oxidation gives you the E cell value. Yeah. Components. So we have hydrogen gas. I think you've got hydrogen gas in this one, and it's at 100 kilopascals pressure. You've got platinum electrode. You've got 298 Kelvin, obviously standard temperature, room temp. And there's one other thing which I can't remember. I've forgotten the last thing. 1 mole of H plus ions, right? Which is just So in the case of HCl, it would just be 1 mole of HCl or 0.5 moles of H2SO4. So forth. Let's go. Okay, the fact that platinum's inert as well. That's fine. Okay, I got everything then. Limitations of fuel cells. We established this already. Expensive. I'm going to turn off my iPad just so I don't look at that. Expensive, flammable. And when I say it's expensive to store and expensive to transport. It's flammable and it's also simply getting the hydrogen and oxygen in the first place through electrolysis requires energy, which is usually found from fossil fuels and so is still polluting. Yes, let's go. Okay. Notation for this one. So remember it was ROOR. So in this case, the more negative one's going to be on the left, so it's going to be this one. So it's going to be Fe solid, straight line, then Fe 2 plus, so this one's aqueous, then double line. Then we're going to put Mn 2 plus aqueous. I can't say aqueous. Is that how you say it? And H plus, and then that's aqueous as well. And MnO4 minus also aqueous. Straight line, and then because it's we need platinum in it because it's all solutions. I don't know if any of that made sense. It made sense in my head though. Let's see if that's right. That's correct. Let's go. I'm actually understanding this topic. Okay, that's good. Usually I have to go through this a few times, but this one kind of it clicked, so that's good. How can you use the electrode potential value to find out whether oxidation or reduction takes place? So no problem. Negative oxidation, positive reduction. So the more positive it is, it gets reduced. So the more positive one gets reduced. Yeah. Steps for alkaline ore. This is the one that I don't remember. I can't do this one. Okay, so first thing is that hydrogen reacts with something. It reacts with the OH minus ions. So H2 reacts with OH minus, giving, I remember it was water and 4 electrons. Now I need to balance this. If it's 4 electrons, then surely we're going to have 4 OH minus ions, right? And how many? Well, I'm just trying to. Okay, if we've got 4 oxygens, we're going to need 2 waters. If we need 2 waters, we're going to need 2 hydrogens. That's the first step, isn't it? So hydrogen reacts with OH minus. I got that. Oh, I got that. Okay. Next step though. So I got this one. What's next? So now is it the water or the hydrogen? No, I think it's both of these. Both of these react with the oxygen. So we're going to plus oxygen. I don't think it's 4 waters. I think it's just water plus B minus plus oxygen gives you OH minus. Is it just that? It's 4 OH minus? That can't be right. I think it's 2H2O then. 2H2O plus 4E minus plus O2 gives you 4OH minus. Yeah, okay, I got it. Let's go. I'm not normally this good when it comes to these chemistry flashcards. I normally am much worse. I don't know what's going on. And then overall equation, so we've got hydrogen plus water gives you oxygen. No. Hydrogen plus oxygen gives you water. H2O. Let me just write that again. H2 plus O2 gives H2O. How do I balance this? 2, and then we need 2 here, like that. Oh yeah, it's what's 2H2 plus. Yep, there we go, and that's the diagram again in case I want to have a look. Yep, that makes sense. Okay. Oh, I didn't put potassium hydroxide solution as a flashcard. I might do that actually. But everything else is fine. Okay, that makes sense. That's good. So, the notation for SHE. Oh, I can't remember this one. I think it's platinum, then hydrogen, then H plus, and then because it's copper, it would be Cu2 plus, and then Cu. Yes. Okay, I got that. Advantages of fuel cells: they are non-polluting if you think about the fact that only water gets produced as a waste product, and they are pretty efficient. Yeah. Why don't fuel cells need to be electrically recharged? Because you're constantly getting fresh oxygen and hydrogen, and so the reactants are constantly being replenished. Yeah. Salt bridge is important because firstly, salt bridge is dipped in. What was it dipped in again? Oh, I can't remember. Wait, what was it? Oh, I just skipped it. Nice. What was it? Connect circuit and filter paper soaked in potassium nitrate. I forgot that. Okay. Electrochemical cells are made up of a voltmeter, a wire, and a salt bridge, and half cells. But I mean, that makes sense. High resistance voltmeter, so it doesn't allow current to pass through. And then once again, it was what? Potassium nitrate. It got dipped in, and it connects the circuit to allow the ions to pass through to conduct the charge. Yeah. Let's go. We did it. I have 198 flashcards in my other notes, but I finished it here, so that's fine. Let's go. We did it. We got through electrode potentials. I don't want to do integration now. Should I? I might have it. I might make a start on integration, but I don't think I'm going to do much of it. But we'll see. We'll see. Yeah. Okay. I'm gonna probably start with integration now. So let's do that. So we spent what 1.5 hours going over electric potentials. Now it's time to do some maths. So this should be fun. I'm gonna probably do maths until 7 p.m. and then I'll probably be done with this. So yeah, let's do that then. Just pulling up the textbook. Here it is. I think I've got yeah, here it is. The reason I've got this open is so I can go straight to the topic that I need to go to, which is integration year 2. I don't even know where I'm at with this topic because I missed a lot of lessons. So I'm just gonna go over all of it. Why not? And then see. I don't even know if I can go over all of it because it's a huge topic. What? Wait, where is it gone? Am I even on the right textbook? Oh, I am. Yeah, look. It's got 12 different parts. What? Okay, I'll try and do as much of this as I can, but we'll see. We're going to start from the very basics and just work our way up. I just want to see if I made any notes on integration year 2. So I've made the year 1 integration notes, obviously. That was a year ago. I don't know where my year 2 integration notes are. I've made a few. I made a bit of notes on this. Okay, that's fine. Oh, I don't want to do this. Oh, I don't like this. I've done enough today. And I still have normal distribution to do. I might just not do any of this. Okay, I'll make a start on integration, and then we'll see how it goes. So should I do, wait, I've done this. I remember doing this topic, this part of integration, like the very, very basics, but I've already forgotten all of it. And then what is this? Integrating f ax plus b. What? What? No, this is gonna be fun. I really need to go to my teacher and ask how to do every single one of these. So now we're doing some integration year 2. I hate maths right now. Anything to do with maths, I just can't be asked for. But let's do this. This should be fine, I think. I just need to understand what's going on first. I think I have. Wait, let me just check. and open up some slides, which I don't know if it will show up on the thing. If I just open up, what topic is this again? This is integration year 2. So if I just open that up, year 2, chapter 11 for year 2. There we go. I don't know if this is going to show. Um, let me check. How do I make maths notes? Oh, so for maths, I don't really make notes. It's more just like example questions. So let me show you. I don't know if I can. Yeah, so for example, for integration 2, I'll show you what I've made so far. This is all during the lesson, right? I've got like a okay, let's focus now. I've got like these equations and stuff. I've got like the equations here for integration, but the most important part for maths, right, is to have these like example questions where I go over how to do some like questions, and so when I'm going back over this topic, I know exactly what to do because I can look over the example questions, and then once I do that, I can then just go straight into past paper practice and like questions and stuff, right? Because that's majority of maths is simply just being able to do that. So let me get to another topic that I've actually completed the notes for. So, for example, let's go to trigonometry and modeling. So, you know, the stuff on like addition formula and things. I don't know if you guys have done that. So, like this stuff, right? So, as you can see, I've got like example questions. So, I've got like the main stuff that I need to know first. And then I've got example question. And they're all just like example questions here. Just lots of them. And then wait, if I go back up, double angle formulae, and then once again I've got more example questions. And then once again, every like heading is a new like a new subtopic, and then I just do more and more example questions. And the stuff in light blue are things to like assist me in terms of how I did the question. So when I look back over it, I can understand what I've done. But like the things in light blue, I wouldn't actually write during the exam myself. The things in white would be the things I'd write if I actually did that question, as if it was an example question, basically. Yeah, I don't know if that made sense. Losing my voice now. I've been speaking too much today. Okay, going back to integration year 2. Wait, where is that? I've lost it. There it is. So I usually make the example questions in class myself, but sometimes I just do them at home. It really depends. My maths notes I don't use as much as I do for biology and chemistry, but they're still nice to look over. Okay. So I haven't started this topic yet. Let me just show you this one. I don't think I've done integrating f(ax) plus b by myself. I know we've done it in class, but I haven't actually looked over this yet. So I'm going to start with this. So if you know the integral for a function, you can integrate in the form f(ax) plus b. Oh, what? What is going on? Okay. So we've got cos. I hate this. I hate this already. Cos 2x plus 3. Okay, so I know that when you're integrating cos, it becomes sine, right? Yeah, y equals sine. I didn't even say that. Y equals sine plus 2x plus 3 times 2. Oh no, I do remember doing this. The thing where you like multiply it out at the end. What? Oh wait, no, I have made notes on this. I didn't even realize I made notes on this on the next page. It's just I couldn't fit it all on one page, so I moved it to the next page. So I've done this topic already. You know what I'm going to do? I'm going to start off with some practice so I can get back into the mood of integration because I clearly have no clue what's going on right now because the last time I did this was ages ago. How to revise for A-level mocks? Which subjects in particular do you want advice on? I keep getting demotivated to study. Any tips? I think for me, it's just a case of making a note of everything you need to do and just doing it. I literally I have nothing else to say. This morning I made like a to-do list of things I was going to do. Come Come on, camera focus, focus, please. Let me just wait. Let me change the camera angle again. There. Okay. Hopefully it can focus now. Yeah, there we go. Electrode potentials, year 2 integration, and normal distribution. And I've literally been sitting here doing that stuff. And yeah, today's been the most work I've done in these entire holidays, and it's just literally just been me sitting down and revising. So yeah, it's been decent today. Maths, physics, and CS. Well, I can only really help with maths, I guess. I think my main advice for maths is to have a list of all the topics, and then being able to like rank them in terms of how confident you are in them, and just making sure you're pushing the bottom ones up as much as you can. Pretty much, that's my advice. But I think the most important thing in maths is to constantly go over the topics, because it's really easy to um, forget how to do types of questions. So it's really important to continuously go over the same things over and over again, just so it's like it like sticks in your head, pretty much. Okay. Let's start with some practice then. So we're going to just do this example, this exercise question over here, these exercise questions, I mean, and see how it goes. I can't lie. I think, now that I'm thinking about it, I think I've done enough today. I'm looking at this and I'm like, the thing about maths is you can't do maths if you're not in the mood to do maths. Like, I can't ever force myself to do maths. I have to actually want to do maths. Otherwise, I just can't focus, because I need my full attention when it comes to maths. Biology and chemistry, sure, I can kind of be like in my own world, and I'm still doing it. But maths, I need to fully be in the moment and understand what's going on. So I'm deciding that I'm probably going to stop my revision there, because I don't think I need to do maths right now. I finished off electrode potentials, and that was my main aim for today, and I'm glad I've done that. That took me about 4 hours or so. I think I've done enough today. I don't know why I did so much today, but yeah. I was planning on doing more, but normally what happens with the reviews is I always think that I'm going to spend 1 hour, 2 hours max doing a review of a topic, and then I end up spending 3 or 4 hours. It just happens. So I'm probably going to just not continue going, because even if I do go over integration right now, it's not going to help me, because I'm not in the state of like actually learning it. So there's no point just shoving it all into my head. I might as well just stop revising. I think I've done enough for today. I'm very happy with the amount I've done today. So yeah, do you guys have any questions or anything? Any queries about whatever? I don't want to do any work anymore, so we're just gonna sit here for a bit, and I'll probably stop the stream very soon. Um, my main reason for doing all this revision today, I keep on getting comments from people saying, why are you revising during Christmas? Well, firstly, I'm not celebrating Christmas, so I might as well do this. But also, I'm filming a day in the life today where I do a lot of revision. And basically, I was just waiting for the day I would finally get motivation to sit down and revise. And suddenly I got it today. So I was like, okay, I might as well sit down and get these topics out of the way. And I've been filming myself as well. And I've actually gotten quite a bit done. So I'm happy. I think I'll probably continue with this stuff tomorrow, but not do as much. I'll probably just do integration a bit, and then for the rest of the holidays, not really do as much. Like, I showed you guys my timetable of things I need to do today. Let me just show it again in case you haven't seen. So in terms of my Notion page here, my things that I need to do today are the follows. Not today, but in the holidays. These are all the things I have to complete, just 4 things. So I've put myself in a good position where I don't need to do much anyway. So I don't think it's I don't need to do too much really. So it's fine. Yeah, I think that's enough revisions for today. I do not want to do any more. I am good. I'm fully tired now. Yeah. Okay. Let's see what you guys have to say. When did your holiday start? Mine started last week. So all of last week I was off, and I was doing everything that wasn't to do with work. So that's why I decided this week I'm going to start off quite strong and actually do a bit of work. If I start the week off strong, then I end up maintaining that across the week anyway. So that's why. How did you get that animated coffee icon? Oh, on my Notion page. It's just a GIF. It's just a GIF that I found online. Yeah. I might make a video on Notion and how like my Notion setup is and stuff like that. I don't know if you guys want to see that, but let me know. Are you an aspiring medical student? I am. I have done my like UCAT and BMAT and currently sitting through interviews and things as well. It's a lot of stuff. I do want to talk about it after I get all my offers and things. So yeah, we'll see how it goes. It's definitely a stressful road, but it's not the worst thing. I thought it would be worse, to be honest. Have you ever had a rest day with no work? Yes, I have. Now, this is making me seem like I'm someone who just does and just non-stop revises. I'm not one of those people, okay? Um, I'm not even kidding. The past, like, because when did I have my Cambridge interview? I had it like quite recently, and the day after that was, I'm not even kidding. I spent the entire day in bed. I couldn't do anything. I was so drained from that interview that I just didn't want to do anything. And for the like days afterwards, and for like the week afterwards, I didn't do anything. Most of my days, I don't do any revision. The only revision I do is perhaps a bit of time on Remnote, going over my flashcards. That's literally all I do for the majority of my time. If I'm during school and stuff, I would actually after school sit down and do a bit of revision and go over the stuff I've learned. But apart from that, I don't revise every day. So yeah, don't worry. I'd like to say I'm on the other side. I don't do actually no, I'm not gonna. It depends on the day. Like during the weekends, I don't do any revision. I usually keep my revision for weekdays. I don't stick. I stick to that. I don't do revision on the weekends. That's just something I do. I mainly spend my weekends on videos and editing and things like that, and that takes up too much of my time. So I just don't have time for revision on those days, apart from like the occasional Remnant flashcards or whatever. Um, I'm in year 12 currently. Integration trigger identities is the easiest so far. Yeah, just wait, wait. Next year, I'm just wait, okay? Next year, don't even. Last year was so nice. It actually was such a breeze. I remember I was playing games every lesson in maths, but now I can't even do that. It's so depressing. Maths lessons are too much now. The amount of content we get through in maths is a lot, and I'm fully like struggling by the end of every lesson nowadays. Um, did I get any homework? No, I didn't get any homework from my teachers or anything. All the stuff I'm doing is just me making sure that I've reviewed everything myself, which is kind of what you need to do for A levels, anyways. It's about reviewing everything after you've learnt it. But this stuff that I'm reviewing is things that we went over ages ago, and I haven't had time to review them because of interviews and things. So I'm finally getting the time to review them. um, Cambridge student, I have not. I'm not very familiar with people, especially Cambridge students. I don't. Yeah, no. Um, yeah. Okay. I'm probably going to stick around for a tiny bit more and then probably stop the stream. I hope you guys found this quite useful. I was gonna do revision anyways, but then I decided why not do it on stream. So I think a lot of people actually found it a bit useful. I'm surprised we got this many people on Christmas. So um, yeah, I thought it'd just be me here. But it's good, I guess. Um, don't worry, you're not gonna become depressed in year 13. You would just lose it for a bit and then be like, oh, it's not too. It's like a cycle, right? In year 13, it's not like you're constantly depressed and stressed, whatever. It's like some days everything's so easy and you're like, oh wow, this is all good, and then suddenly it just goes down and you're like, I can't understand anything. There's too much, and then goes back up again. It's like this fluctuating cycle. It's hard, but it's definitely not as bad as people say it is sometimes. I think it's definitely doable if you continue the stuff you do in year 12 in terms of like revision and like reviewing everything. Year 13 will be fine. It won't be too bad. But it's just the content, just warning you, big jump. Just be prepared for it. Especially for maths. Maths, big jump. But for biology as well, biology was quite a big jump as well. Chemistry, not as bad, but yeah, that's what I have to say about it. Um, how are you preparing for year 13 to uni transition? I can't lie, I'm not doing any preparation for uni or anything yet. I mean, right now, I just want to make sure I get any offers and then probably after A levels, focus on that. Even after A levels, I don't think I'm going to do much towards my university or anything. I'm going to probably spend that time focusing as much away from work as possible and just enjoying that summer because I don't care about this A level stuff anymore. I just want this all to end. But to be honest, I actually kind of enjoy it from time to time. I'm actually going to be sad when year 13 finishes. This is my last year and then I'm done with like school. So that's kind of sad, you know. But I don't know. Yeah, GCSEs don't matter for university and things like that, but it depends on the uni, so be careful. Some unis do look at GCSEs, but as long as you do, like, if you get like a grade 5 in, I think it's grade 5 in GCSE English Language and Maths, then you'll be fine. That's the most that many unis look for. I know that Oxford, I think, put a bit of weighting towards GCSE grades, but that's all I'm aware of. So I'm not entirely sure. I think you'd have to do your research on that. But just don't stress too much about GCSEs. They're not that big of a worry when it comes to uni stuff. The only thing you'd really need GCSEs for is getting into a good college if that's what you want to do. It's up to you, I guess. Have I been going to the gym? Yes, yes, I have. That's one thing I've actually been keeping up this month. I think I've actually this month I think I've gone the most I've done in a long time. Let me just pull up, but it's not a lot, okay? But um, I'm just pulling up my gym. You have to also realize that I had an interview halfway through the year, and you can clearly tell because there's like a big gap. So did I say halfway through the year or halfway through the month? That's what I meant, halfway through the month. Acids and bases has to be the most difficult chemistry topic I've done this year and last year. So confusing. But even after I understood it, it's so easy to forget everything that I have to constantly go back over it every single time, only for it to go back out of my head again. It's such an obnoxious topic. I honestly hate it so much. That topic, I've never spent so long just staring at the same question as I have for acids and bases. Honestly, the worst thing. And also the fact that my chemistry teachers are rubbish, so I didn't understand anything. It was horrid, horrid subject. Currently just opening up my thing. It's not even loading, but you know. um, yeah, I don't know. I'll see. I'll see how it goes. The stupid app isn't loading, which is annoying. Okay, let's see. Do you want to go to a uni more clinical based or more content based? To be honest, I don't mind either. Like both of them just have their pros and cons. I literally don't mind either way. They both seem like a nice like I don't mind either one. So that's all I have to say to be honest. We'll see though. My biology teachers, on the other hand, are actually pretty decent compared to my chemistry teachers. My biology teachers are actually like they actually put effort into every lesson, and I actually understand what's going on. Whereas chemistry, I'm so lost half the time. I don't know why am I saying half the time. All the time I'm lost. I don't know what's going on. So yeah. Okay. Yeah. On that note, um, I'll probably stop the stream very soon. I'm tired of revision. I don't want to do any more of this. But I'm happy that a lot of you guys stuck around today. I don't know if I'll do another stream like this very soon, but we'll see. If you guys do find these type of videos useful, let me know. If you guys like these like live streams of like study with me's and things, it helps me actually get some work in, and maybe it might motivate you guys to do work as well. I don't know, but I personally find them useful for me. But if you guys want me to do more of them, let me know. But we'll see, I guess. Um, I got quite a bit of work done, so that's good stuff, I guess. But thank you. Yeah, I'm probably gonna get going now as well, unless anyone's got any more questions they'd like to ask. But yeah, I'll probably log off from this stream. I'm glad we got this many people, which is good. Study with me lives are motivating, really. I mean, I personally uh, thought that it would be more distracting, but if you guys want me to do more of these, I'll gladly do them. It's just like because I'm gonna be doing work either way, so if I might as well like live stream it. We'll see. Yes, make sure you start your chemistry revision. I'm gonna stop my chemistry revision. You can start your chemistry revision, but yeah, I'll stop my stream at 6:30. So if you guys have any other final questions that you'd like to ask, let me know. Why did I just hit my desk? Oh, oh, this I need to finish off my video as well that I'm making for today. But yeah, we'll see, I guess. You can continue trying to guess my uni options, but I'll let you guys know once I get my results at the end. So yeah, specialities. To be honest, I'm not that sure of like what specialities I'd like to go into and things. Um, yeah, there's not any specific ones that I can really think of, but I was gonna say we'll see, but I've said we'll see so many times. Um, but yeah, I'm taking biology, chemistry, and maths. I don't know why I had to think through that one. It's in the description of my videos as well. Um, I use DaVinci Resolve for my editing. I'll just type it in the chat as well. Uh, what's the best medicine related book that you've read? Let me just get it. Let me get it. In the next 2 minutes. Yeah, I found it. I think I mentioned before as well my love for this book, War Doctor. This is such a good book, and it's such an underrated one. When people say to read like medicine books, they normally mention like the really generic ones. Like I'm just trying to think of them. Like This Is Going to Hurt, for example. I haven't read that one. I've read Do No Harm. I've read Being Mortal. I've read When Breath Becomes Air. Those ones are good books as well. This book, though, this book moved me. Okay, this book, I've never had such an enlightening experience with a book as I have with this. That just makes me sound really sad. This book actually was so good. I think I remember talking about it on stream once. I got recommended, I got given this as a gift by one of my friends. They just had one spare, so they just gave it to me. And I started reading it during my Cambridge Open Day when I was going to that. I was like, okay, I might as well read this. And very, very good book, honestly. It's a very sad book, and I didn't expect that. I just thought it would just be another medicine book. It's actually really good. So, oh no way, that's actually really cool. You got to meet the author. Wow, I'm actually really, really jealous. Predicted A star, A star, A star, and received all of my offers. Fair enough. Congratulations. Honestly, you don't need to stress. Like as long as the unis that you've applied to are unis that you can see yourself going to, you don't need to care whether or not they're good unis or whatever. Don't fall into the trap of being like, oh, I don't like. Don't be like, oh, I want to get into this uni because it's a good uni. Think more of how you like when you're applying to a uni, look at whether or not that uni has the things that you would potentially. Because if you're talking about, like, for example, for medicine, for example, like the course is going to be the same wherever you go. It's more the case of do you like the location, do you like the way it's taught, stuff like that. I think that's more important. So don't stress too much, to be honest. But yeah, that's all I have to say to you guys. Like, you don't, because you've already gotten the offers and things, right? It's already been done. Don't stress about, oh, I should have applied for X and Y or whatever. But like now you've gotten your offers, just think between these and which ones you like to go to, and use that as your like. Yeah, I don't know if that makes sense, but don't worry. That's my main advice. Just don't worry. Even if you do have that feeling of, oh, you should have perhaps applied somewhere else. I still get that right now. I haven't gotten my offers yet, but I still keep on thinking, oh, what if I change my offers, change my uni? Sorry. It's like whatever you choose. At the end of the day, you're always going to be thinking, oh, what if I had chosen something else, whatever. So it's fine. Don't worry. Just choose something. You've gotten your offer, so you've made some like you've gone for smart choices, so it's fine. Like just choose whichever one you see yourself going to the most, and that's all that matters. Um, 2 days. Wow, it took me like couple of weeks to finish War Doctor, to be honest. But it was the first like non-fiction book that I was consistently picking up, and I was like, oh, I can't wait to read the next chapter, which sounds really sad, but honestly, if you haven't read out this book, it's really good. Yeah, I'm considering taking maths for A level, but I'm on grade 6 to 7. Do you have any tips on how to get a grade 8 to 9? I've got a maths video if you've checked that out already. Most of the things I have to say I've already said in that. But I think the most obvious thing is to practice. The way I recommend doing it is to have the list of topics by your side and to consistently be going over each and every topic and making sure you're consistently ranking them and changing, like moving them about. So at the bottom, you have like a few topics that you're the weakest at, and you're consistently practicing those so they can go higher up. And then you have new topics that come to the bottom, and then you can practice those ones, and you just continue doing that to the point where everything becomes really, really strong. That's my main way I revise maths. I just consistently go over topic by topic everything I can, and then obviously lots of past paper practice as well. That's my main advice. Yeah, Corbett maths is really good. I use it a lot in GCSEs. I don't use it as much for A levels. I don't even know if it has A level resources, but nowadays for A levels, I just use the Edexcel textbook and like Maths Genie, for example. That's mostly what I use, and a few YouTube videos. That's it. But yeah, yes, I have done my BMAT exam. Um, yeah, I do want to save my results and everything for the like results video when I talk about my unis and things. So we'll see. And yeah, PMT I don't recommend using for like just you overall just as your only source of notes and things. Make sure that if you are reading through PMT or you're like going through the flashcards or whatever, to have the specification by your side or have another YouTube video that also goes over the topic and to compare and make sure that you understand everything, because PMT does sometimes neglect information or sometimes include information that's not actually needed. So I never really recommend using only one resource. Always use multiple, and then use always with the specification by your side, just so you know that you're actually covering everything you need to. That's my main advice. But yeah, so as in A level, for example, I'd usually use PMT sometimes, Chem Revise, YouTube videos. I do all of them at once, and so I get the best things from all of them. Yeah. Okay, I am probably gonna see you guys now. I've been on stream for about 2 hours, so it's been a productive stream. I think we've actually gotten the most work we've done in a long time, so that's good, I guess. But um, if I go to a London uni, would you accommodate or commute? I would probably just travel because I live in London, so I might as well just travel. Okay, like I wouldn't really spend accommodation fees if I live in the city already. I'd only spend accommodation fees if I'm living abroad, not abroad, like you know what I mean, outside of London. Any unis outside of London, I'll pay for the accommodation and stuff. But London itself, yeah, I'm gonna just commute. It just works better, I guess. I'm losing my voice now. There's no way I'm doing a 12-hour stream. I don't think I could survive that. Honestly, it's only been 2 hours and I'm actually like I'm drained. My voice is going. And I need to change this camera setup for next time because it's very weird. I'm just like staring up like this, which is just creepy. But yeah, okay. Thank you guys for joining my stream today. We've had a total of 531 people, which I'm very grateful for every single one of you guys who've come along today and checked out the stream, even if it was for just a short amount of time. Thank you on this Christmas day for attending my revision stream. Don't worry, I'm not going to be revising anymore, just to let you guys know. Don't worry, I'm actually going to relax now. And yeah, what's this question? Do people laugh at you for having a YouTube channel? No, not really, to be honest. Um, no, that's I've actually had quite a few like fan interactions. Like I've had people who like come up to me and be like, "I've seen your YouTube videos," and I'd be like, "Oh, that's cool." Um, yeah, nice. But I don't know, not really laugh at people. I don't get any like negative reception from people for having a YouTube channel, you know. But yeah, I'll see you guys. Make sure you revise if you haven't already. At the same time, though, if you want to take a day off today, go ahead. The only reason I was revising today was because I haven't been doing any revision yet. So yeah, I'll see you guys. Bye for now. I've said that like 20 times now, and I'm still here. So I'm actually gonna go now. But yeah, we got a lot of revision done today, so we'll hopefully do a similar thing very soon. Bye, guys. Still have like 20 people here. No worries. I'll hopefully do more live streams. I actually really like doing these live streams and things. They're very fun to do. But yeah, just sitting here in silence, waiting for you guys to go. Try to lower the grade boundaries by telling people not to write. I don't even know what to say to that, honestly. Yeah, you know what? That's a really good idea. I might do that.